looking at position isomerism, and this is not even hard because we said in position isomerism, it's a type of structural isomerism, and we said it is the position. Okay, there we go. It arises from differences in the location or position of the functional group in each isomer. Remember, when we say we have isomers, there should be two things. You'll be having it like some two things that are next to each other and they are different. And where is the difference coming from? The position. Okay, the position. You can have even up to 4 different things. You can have 4 different position isomers. It's not only 2, it can be 3, it can be 4, but there will be it'll be more than one. We can't just say one thing is an isomer. What do you mean by that? It's an isomer of who? When they are isomers of each other, then something is changing in the two things. And here it is the position of your functional group. So they have the same functional group, but the location is what is changing. In other words, remember that when we are saying the position of the functional group is changing, the chain remains the same size. So in here, let's put some examples of position isomers. We could have it like this. We could have, can put 1, 2, 3, 4. I'm going to put 5 and 6. These are 6 carbons, okay? And I'll put an OH here, right? And I can have again 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I'll put OH here. And again, I could have 1, 2, 3, 4, 5, 6. And I could put OH on the third one, right? So these 3 are isomers of each other because this is butane, this is hexane, this is hexane 1O, this is hexane 2O, okay, 2O, and this is hexane 3O. What is changing? The position of the OH group, okay? So this is an example of position isomers. These are position, this is position isomers. This is example of position isomerism. Remember, if I have it here, then it is not going to be an isomer of this. These two would be hexane 2O if it's here. Because look, I just start counting from the side, which gives me the smallest number. We know that. So here I'll start counting from the right so that I get 1, 2. Here I start counting from the left, so I still get 1, 2. So they are not isomers. But when I put it here, then it is an isomer because I can start counting from the left so that I get 3 here. Okay? Or I could put it here. It will still be 3. I start counting from here, 1, 2, 3. It'll be like this. So here we have isomers. This is now hexane 3O. These are isomers. Let's put another example. Another example is, let's say I have 3 carbons. I'm going to put 1, 2, 3. Then I'm going to put it again like this. Then I'm going to put it again like this. Then I'm going to put it again like this. Okay, I'm going to have 4 possible isomers of guys that have BR because I can have BRB on position 1 and position 2 like this, or I can have one on position 1 and the other one on position 3, or I can have them both be on position 1. Okay, I'm leaving out the hydrogens so that I don't waste time. Or I can have them both be on position 2. These are 4 different isomers of dibromopropane. This is dibromopropane. Here we have 1,2-dibromo. Here we have 1,3-dibromo. Here we have 1,1-dibromo. Here we have 2,2-dibromo on the last one. So, and we can put the hydrogens. I mean, it doesn't change anything. Okay, so the bromine is the one which is the functional group, the bromine and carbon with their bond there. So we are looking at its location. So that is what we are saying. These are your isomers. These are position isomers. Look at the chain. Both are 3 carbons. 3 carbons in the chain, 3 carbons in the chain, 3 carbons in the chain. So in position isomerism and in chain isomerism, the functional group doesn't change. They are of the same functional group. What's the functional group? Haloalkanes. Here, what is the functional group? All are alcohols. Okay, but the position or location of the functional group is the one that's changing. All are alcohols. And if you see, all of them have 6 carbon. They have a 6 carbon chain. Here, all are halogenoalkanes and they have a 3 carbon chain, all of them. But the location is what changing, the position. So that is what causes position isomerism. Let me show you things that are not position isomers, okay? Things that are not position isomers. Things that are not position isomers. They are not even isomers. What are they? If I show you something like this, if we have something like 1, 2, 3 like this, right? And I put another thing which is 1, Remember, when we say isomers, we'll be comparing. So here, we can't say we have isomers, two different isomers when we have something like this. Let's say BR is here and the other one BR is here. Then here we are going to have a BR up here and a BR down here. Or we can now have a thing like this. We can say, let's just say we have it come like this, and then we have one, we have I could put a BR here, and I could put a BR here, and I could put another BR here, or even like this. Then I can put hydrogens however I want. These are not isomers. Here we don't have isomers. Do you know why? Look at the chain. What is the length of the chain? 3 carbons, 3 carbons, 3 carbons. Okay, what's the length of the chain? This is 3 carbons. That's the length of the chain. It's continuous. You can go down like this. So the chain is 3 carbons. Which positions are my bromines at? 1 and 2. So 1, 2. Here 1 and 2. So 1, 2. Here 1 here and 2 there. So it's still 1 and 2. Even if it was like this, even if the bromine was here, it would still be 1 and 2 because I'll start counting from down here. It's still 1, 2. So these are not isomers. Be careful. Don't be confused by bending like this when the chain is still the same. No, be careful. Watch out for that. They won't be isomers. Okay, so this is what you have on position isomerism, and we've reached the end for this. Now we'll go and do the last one, which is chain isomerism. In the next one, we meet in the next video. Goodbye for now.